So yeah, we can record with this and recording has started. Good. Yeah, can everyone see my slide? Yeah.
Yeah, we can
Hello?
see it.
Oh, smashing good. Excellent. Good. So what we're going to be doing today is simply an overview of systematic review and meta-analysis. You know, what we're showing you today is a snapshot of how to go about a systematic review. Now, if you're working as from what you were in multiple cities, we're in different countries. Some people are joining in from Lebanon. We got people joining in from different countries. Now, if you're going to be working with a large collaborative, most of the research you're going to be doing systematic review, because if you can't do a primary research where you would require to go take patient details, that would be very difficult because you can't have someone flying in from Australia just to come take patient details from Nottingham. So most kind of work we do is systematic review, and that's the most kind of work you're going to be seeing around the Frankenstein research fellowship. So that said already, outline is, like I said already, my name is Chinedu. I'm a specialty registrar in orthopedics. I'm also a spine fellow. Outline is, we're talking about the what, the why, the how, the advantages and disadvantages of systematic review. So I want us to just think about this. What do you think is systematic review? Just think about it for like 20, 2 seconds. What do you think in your mind is systematic review? I hope what you thought about is systematic review is actually a high level overview of a particular research question. So what it does is it systematically identifies the relevant information. It then selects which of those information that is out in the internet, which of them do we need for this to answer this question. You evaluate that information or that piece of evidence you've gotten, and then you synthesize more. Synthesize it means you then make sense of it. And then you do this for all the high quality research evidence relevant to answer that question you have in mind. So that's what systematic review is. It's not just it's a means of answering a question which is systematic, and you're sure that you're answering the question using all the available evidence. So think of it like a super machinery, where on the left side of your screen you have this multiple papers, which is you find in different resources. You pull them through this machinery. This machinery then systematically identifies which of them is relevant, selects the right ones, evaluates them. Then you can see on the central and the right side of the screen, you can see a clean pile of information which has been already synthesized using a systematic review. So that's what it is. Think of it that way. Remember this picture, and that's all you need to remember. It's simply what we talked about. It synthesizes the results of multiple primary studies related to each other by using strategies to reduce biases and random errors. Now, think about, say, another 3-4 seconds. Think about in your mind, what is meta-analysis? What do you think is meta-analysis, in your mind? Good. So I hope whatever you thought is meta-analysis is that meta-analysis is now the use of statistical techniques, in a systematic way to integrate the results of the included study. So think of it this way. So think of that machinery and the amount of pile of paper it has produced after synthesizing all the information, all the high quality information. So pile of paper would not mean anything to you. It's rubbish. You need to then ask yourself, how can I use this pile of information to make a reasonable inference, to actually make sense of things? And that is what meta-analysis is. And this picture drives home this point. So you've done all your systematic review, you've pulled everything together, and then you've gotten those papers that you think are relevant. Now, meta-analysis is then using your methods to piece that puzzle together. So think of it this way. You could say what they're doing. They are trying to match the shape to the gaps. And that's how you can pull this together. That's what meta-analysis is all about. So that's what I want you to remember. Whenever you think about meta-analysis, think of this picture as well. There are different types of meta-analysis. You don't need to get bogged down about this, but it's just something you need to know for something that could help you. So you've got your cumulative meta-analysis, which is where you've designed your systematic review, you've done your meta-analysis, and whenever a new study is being published, you pull it into that meta-analysis and see if it changes things. So that's what it is. So you just keep adding as time progresses. Whereas the retrospective meta-analysis is the one we do commonly. So we just go in, search at that point in time, what do we have out there, pull them together, and perform meta-analysis on them. And that is what your meta-analysis is. And that is what, like I said earlier, the commonest ones we use. Just give me 2 seconds. Let me send this link to someone. Good. And then you've got the other one, which is the prospective meta-analysis. And in this regard, what you do is you design a criteria or protocol for selection of the relevant studies. So you've designed the machinery. So whenever a new study is being published, even before the studies have been published, you just design it. So for example, Tesla, they have super robots that build their cars. So they program these robots to build the cars. The robots are there. And whenever a new part of the car comes in, they put it in the robot builds that car. So that is what it is, prospective. Prospective means you've designed it and then new studies, you add onto it. So that's what it is. Now, think of systematic review as well as this image. So you've got this set of orange, nice, circular background. Whereas this is what meta-analysis is. So meta-analysis is a way of making sense of systematic review. But you can see meta-analysis is a subset in the sense that it's not everything in systematic review that you can do a meta-analysis for. So if you can't do a meta-analysis for any of those information or conglomerate of studies, then that methodology would be what we call a narrative review or a qualitative review. So if you cannot meta-analyze, so you can see a large set of systematic review, only a subset you can have a meta-analysis for. So what happens to the other subsets that we can meta-analyze? Those ones, like I said, are the ones that you then narrate rather than analyze. Now, the next question will be, at what point should we be able to perform a meta-analysis? There's a criteria for it. Studies that answer the same research question. So for example, Rodrigo et al. Answers the question about, for example, volar plate, outcomes of volar plate fixations for a distal radial fracture. Veronica et al. Answered the same question 2 years later. Alexa answers the same question. And probably Raffia does the same thing again, probably 3 years later. So all these questions were answered. They are similar questions. So you can then pull this together in a meta-analysis because they are very similar, because they answer the same question, similar question. Their outcomes are comparable. So hopefully the outcomes are comparable. So for example, Rodrigo was looking at the outcomes. He was looking at probably the, say, radial height, radial inclination. For example, Raffia was looking at radial height, radial inclination as well. And Veronica was looking at radial height, radial inclinations. You can see they're all similar outcomes. But assuming that while Rodrigo was looking at satisfaction, that is how satisfied the patient is, Veronica was now looking at probably the radial height and radial inclination. And then Raffia was probably then looking at something different, probably looking at how clean the scars look. So these are different outcomes. You would struggle to meta-analyze them. You want similar outcomes. You want to also, you want a study that the data is extractable because you deal with figures. You want data to be extractable. You want the studies to be sufficiently similar. The quality is adequate. You have enough studies. So for example, you have, say, one study. You can't do a meta-analysis in one study. 2 studies is just for basic pooling. You can't really do a meta-analysis. You will be able to do a meta-analysis for studies that are about 5 and above. However, sometimes some of the things we are trying to investigate are rare. The literature is sparse. So in that regard, we could probably then do, 3 maybe, but 3 is the least you can ever do systematic meta-analysis. 2 is just, taking a piece. Then, this pooling adds meaningful insight. So those are kind of things that, you could then perform meta-analysis for that set of research evidences. Good. I'm not seeing your faces. I'm not seeing your hands. If you have any question, just unmute yourself and ask. Yeah, feel free to do that. So what are the key points or key take-home messages I want you guys to take from this? Systematic review is a well-structured method of pulling all the available evidence supporting a research question. A meta-analysis should not be used as a synonym for systematic review. Sometimes people will say, oh, I'm performing a meta-analysis, I'm performing a systematic review. They're not the same thing. Meta-analysis is a way of looking at systematic review. Systematic review is not meta-analysis. You can perform a systematic review without doing a meta-analysis. So they're not synonymous. A meta-analysis should be done in the context of systematic review when certain criteria are met. And I've just told you the criteria in the previous slide. Why do we perform systematic review? Systematic review, you can see at the top of the pyramid in the pyramid of evidence. It's the top. They are the top level of evidence. And that's why we perform it, because they help synthesize all the information into a very high level of evidence. And you will see down the line why this is important. So these are some of the reasons why we perform it as well. It summarizes all the available evidence, like I've told you already. It reduces bias because there's a systematic way it's being done. It will reduce selective reporting. So for example, imagine that you're trying to search for, you're trying to search for data regarding a particular topic, and then you only go to PubMed. What that means is you'll be looking at information from only PubMed, whereas you did not search Cochrane, you didn't search Scopus, you didn't search Web of Science. These are other search engines or other places where, publications could be found. And it's not all the publications that are found in these other databases are found in PubMed. So when you do a systematic review, you'll be looking at all these databases and you'll be able to avoid selective reporting. It also helps inform clinical practice and guidelines. So think about it this way: a high level of evidence, it's a no-brainer. The big boys would want to use those evidences to inform, decision making. It helps quantify effects. So for example, you're trying to find out what is the true effect, from the example I gave you earlier of distal radial fracture fixation using a plate. You can then say, after pulling data from 15 studies involving, say, 2,000 patients, these are our findings. And think of it that way. Those findings, those quantity effects would speak volumes, right? Because it's large data. And then you also highlight gaps in knowledge. So for example, you're building a house and you've pulled all your materials together. When you pull materials from PubMed, you pull from Scopus, you pull from Cochrane, you've pulled from Web of Science, you pull from, other places. And then after putting them in your house, you then realize that, oh, okay, I'm missing a kitchen cabinet. Oh, I'm missing a toilet door. I'm missing a ceiling here. So you know where the gaps are. And then that information would help fuel future research. So that's one important thing. That's why we perform systematic review. How do we do this now? So we've talked about the why, we've talked about systematic review. How do we do this? You develop a focused research question first. You then define your inclusion and exclusion criteria. You find the relevant studies after doing that. You then extract the relevant data. You then assess bias for those included studies. You analyze the data. You interpret the evidence that you have already analyzed, and then you write up a manuscript. And then there's one part that is very important. You keep updating your systematic review. Systematic review is not, when you produce a systematic review, it's not the end. You need to update it. It's probably, it depends on how frequent literatures are being published in that research question. It could be 6 months, it could be a year, it could be 10 years even. Yeah. But all these components on how to do it, those are the kind of things we're going to be talking about subsequently. So my colleagues and I will talk about this. So I'm not going to go deep into this. These are part of components of what we're going to be talking about going forward. There are advantages of systematic review. In your mind's eye, you already know some of those advantages. I'm going to just spell them out now. You use explicit method to limit bias. You draw reliable and accurate conclusions. It's the best form of evidence, like we've seen from the pyramid of evidences. It's a very useful decision-making tool for clinicians, researchers, policymakers. It increases precision of the result, like you already know. Imagine pulling results from 15 studies, 2,000 patients. That's evidence will be huge. There are limitations. Everything that has a good side has a bad side. There's always the heroes and the villains. What's the limitations of systematic review? It's time consuming. Think about it. If you're going to be pulling information from 2,000 patients from 15 studies, it's time consuming. It's resource intensive. The quality depends on the included study. So think about it this way. So if you have randomized control trials that you pulled together in your study, you would have a higher level of evidence of systematic review compared to a systematic review that is pulled from case reports. So weak primary studies lead to weak overall conclusions. Heterogeneity is like comparing apple and oranges. So because of the different studies, they were done at different times, they were done using different methods, things would differ. But the heterogeneity is one of the challenges that you have in systematic review. But there are ways to try and combat that. And these are ways, we're going to tell you those ways as time progresses, but that's one of the drawback of systematic review. It's prone to publication bias. So for example, where you have, one of the challenges with publication is when you submit a paper to a journal and the paper doesn't have a positive result, sometimes the journals will turn it down. So what happens is the published papers are papers that have positive results. That doesn't mean that is what is happening out there, but because the papers that are published by the journals are biased, and that bias would then transfer into your systematic review. And then when you do a systematic review of those papers, you would think that is everything there is. It's not. There are some of those papers that did not meet the light of day. It's not always feasible. So some studies, you cannot put them together. It's not always feasible. That's a no-brainer. The overall reliance on English, I'm yet to see a French systematic review, to be honest. Most of them are majorly English language related. So the overreliance of English might bias things. I've been doing systematic review, and there's some very nice Chinese papers, very nice German papers, but I couldn't convert them to English. There'll be a lot of problems trying to convert them. So I put them out. So those are the limitations. So basically, take-home messages. Systematic review is an organized method of answering a research question to produce the highest level of evidence. And meta-analysis is now a statistical method of making sense of systematic review. So thank you, guys. So that's basically an overview of